Mechanical hard drives, like this one, have been out there for a pretty long time, and despite the fact that they are slowly getting replaced by solid-state drives, they are still relevant. And today, we're going to take a look at how they actually work. So first of all, this is what a hard drive looks like on the inside. The most important part of a hard drive are the platters. These are the little disks that the data is actually stored on. As you can see, there are multiple platters stacked on top of each other. Each platter has got its own arm. That arm is comparable to the arm of a gramophone. It can move across the surface of the platter. And at the end of that arm, unlike with the gramophone, there is not a needle, but there is actually a magnetic sensor and an electromagnet, which are used to read data of the platter or write data to the platter. We'll talk about the details later on. Now let's take a closer look at one of these platters. Now we can see that the surface of a platter is actually covered with tiny little microscopic magnetic particles, tiny little magnets. Now every magnet has a north pole and a south pole, and schematically that looks like this. Simplified, it looks like this, it's just an arrow. So this magnet has its north pole facing forward. This magnet has its north pole facing backwards. Now what we can say is that when the north pole is facing forward, we can call it a 1 in binary, and when it's facing backwards, we can call it a 0 in binary. And computers store everything, all of the data, in 1s and 0s, so we can use this to store our data. So now let's go back to the platter of the hard drive. As you can see, the magnetic particles are divided into segments by the red lines that you see. In fact, there are not actually red lines in between them on the platter, however, they're just virtually divided into segments. I just made those red lines in a drawing so that you can see what's going on. Now each segment represents one bit, so each segment represents a 1 or a 0. This segment, for example, inside this segment all of the magnetic particles are pointing forward with their north pole, which means that this segment represents a 1. If all of the particles in this segment would be pointing backwards, it would represent a 0. The reason why it takes an entire segment and not just one individual particle is because the right head of the hard drive is not precise enough to turn around one individual magnetic particle. Let's say we want to turn this segment, which now represents a 1, into a binary 0. That means we need to turn around all of the particles. But how does it actually do that? That's what I'm going to demonstrate right now. Okay, so basically this is how it works. Right here we've got our magnetic particle with its north pole facing in that direction, but we want it to face in that direction. We want to turn it around because then it's a 0. Okay, now we're going to use a magnetic field to actually turn this magnet around. So I've got two other magnets right here. This magnet has its north pole facing towards the green one, so they're going to push each other away. Same goes for this one. It's got its south pole facing that way, and the green one's got its south pole facing that way, so they're also going to push each other away, so it's getting sandwiched between those magnets. But at the same time, the south pole of the green magnet is also attracted by the north pole of the blue one, and the north pole of the green magnet is attracted by the south pole of this one. So in theory, the green magnet is getting sandwiched more and more, and eventually it's just going to turn around like that. So I'm now going to demonstrate that. Did you see that? The green magnet turned around and then it got stuck to this blue one. So on the right head of the hard drive there is just a tiny electromagnet. That's basically a magnet that you can turn on or off using electricity. Using that magnet, it creates a magnetic field which then forces the tiny magnetic particles on the platter to point in the desired direction, and that is how it can write a 1 or a 0 to a certain segment. But then the question remains, how does it actually read data off the platter? How does it determine if a segment is a 0 or a 1? Well, right next to the electromagnet that is used to write data to the platter, there is a little magnetic sensor. And that magnetic sensor is able to detect in which direction the north pole of a magnetic particle is pointing. So, when it hovers over a segment on the hard drive, the sensor will be able to detect in which direction the north poles of those particles are pointing, and that means that it can detect if that segment is a 1 or a 0. And that is how a hard drive works. So I hope you've enjoyed this video, and thank you for watching.